Hello everyone, welcome to this module of disaster recovery. So disaster recovery is very important part of solution architects because once you have created your architecture, it will not be immune to the failures automatically. You have to make various strategies, you have to understand that how different components of your architecture can be recovered if any disaster happens. So, this is what we are going to learn in this particular module about disaster recovery and how we can overcome it. So, what are we going to learn in this module? We will be understanding about what is disaster recovery, that is DR, how to make different components like storage, compute, networking resilient to the disaster. What are the different recovery strategies that we can have? So, once the disaster occurred, we have to recover our entire infrastructure out of that disaster. So, there are various strategies for doing so. The first strategy is called as backup and restore. The other strategy is called as pilot light. Next strategy is called as low capacity active mode. And the last type of recovery strategy is called as active. So these are all four recovery strategies that we are going to understand and learn in this particular module. So the very first question comes into our mind is, what is disaster recovery? So let us understand about disaster recovery first, and then we would be understanding about various other aspects. So here in this topic, we'll understand what is disaster recovery and why is it important. So it is a process by which an organization anticipates and addresses the technology related disasters. So it's not possible that once we have created the infrastructure, nothing will go wrong. And the best way to handle failures is to anticipate them. So if we are anticipating failures, we would be obviously working towards those failures. That what if this happens? Okay, so if that happens, your plan should be ready. Now, you should not go in the search of, water when you are thirsty. You should be having a backup plan. You know that you are walking in a desert, so you must be having water with you. IT systems can go down unexpectedly due to any kind of unforeseen circumstances, right? Because there are various dependencies. So we can have power outages, we can have any kind of natural disasters, we can have security issues like cyber attack or any kind of other event that cause significant disruption to our business. So disaster recovery includes a company's plans and procedures to recover quickly from such disasters. So disaster recovery typically involves creating a plan that outlines the steps to be taken to ensure the business continuity, because we don't want our end users to suffer. Even if Google, Instagram, all of these services are even down for few minutes or few hours, everyone gets so crazy. So that's why we do not want our business to get disrupted. We want to ensure business continuity. Along with that, we should be recovering our data, applications, systems, as well as infrastructure. So this plan typically includes measures to prevent and mitigate disasters, such as regular data backups, redundant systems, geographically dispersed data centers. So that's where AWS comes into the picture, the global infrastructure of AWS, right? We have seen that we distribute our subnets into multiple availability zone. What is the reason of that? If one availability zone is going down, we can have our infrastructure up and running in other availability zone. We can have S3. So in S3, automatically our data is replicated across 3 availability zones, making it highly available. So in case of any kind of disasters, when our database instances, our storages, our instance EC2 instances, if any of these goes down, right? We want our business to run. So that's why we have to make our architecture highly available as well as durable. We cannot have our data loss as well. Suppose we are having one banking database on AWS. Some disaster occurred and the database went down. What will you do? You cannot lose the customer of your bank, right? You cannot lose the data of banking customers. That would create a mess and chaos. So to avoid that, we have to make foolproof plans that how we would be anticipating the failures and how we would be coming out of those failures. So in event of disaster, the TR plan provides a roadmap for restoring the operations as quickly as possible. So there are two terms. These two terms are RPO and RTO. Recovery point objective and recovery time objective. Recovery time objective and point objective both are decided by company. Time objective states that how much of time we can tolerate till our business is back up and running. So it can be, few hours, it can be few minutes, it can be few seconds, it depends. And then we have RPO, that is recovery point objective. It means that how much data loss we can suffer. So we can suffer the data loss for last 24 hours, or we can suffer the data loss of just last 1 hour. So these two are the important criteria which is decided by the company itself. So in the event of disaster, as I said that we have to restore our operations as quickly as possible. So what all things we have to do for that? So for that, we have to activate backup systems. We have to restore the data from backups and other recovery tasks are to be done. The ultimate goal of our disaster recovery is to minimize the impact of disaster on the organization and to restore the normal operations as quickly as possible. So all of these things are included into disaster recovery. Now, why it is important? You would have understood till this point of time that why it is important, but formally if we talk, then disaster is something that unexpectedly happens. Okay, it can slow down. It doesn't always mean that it will, shut down or terminate your entire business. No. It can slow down your business. There can be interruptions. There can be network outages. Right? So, these are called as disasters. So, how can these disasters happen? Any natural calamities like earthquake, fire, floods. So, at that time, the data centers might go off where your workload is running. So business will be affected. Any kind of technology failures, let's say the optic fiber that we use for connecting to network broke. System incompatibilities. Human errors, when human does some kind of errors like switches being turned off, then everything goes off. Or any intentional unauthorized access by third parties such as DDoS attack or cyber attacks. All of these are considered as disaster. Here, disaster does not mean just the natural disaster. It can include any of this and anything apart from this, which would be resulting in failure of our infrastructure. or which would disrupt our business. So these disasters will disrupt the business operations, causing the customer service problems, which will ultimately result in revenue loss. When the Google is down even for 1 hour 15 minutes, the shares drop like drastically. So the huge firms cannot tolerate these disasters. So disaster recovery plan helps organization to respond promptly to these disruptive events. And what would be the benefits of these? Includes it ensures business continuity. So when a disaster strikes, it can be detrimental to all aspects of business and it is often costly. It also interrupts normal business operation as the team's productivity is reduced due to limited access to tools they require to work. A disaster recovery plan prompts the quick restart of the backup systems and data so operation can continue as scheduled. So this is how it ensures business continuity. The next is enhanced system security. Integrating data protection, backup, and restoring processes into a disaster recovery plan limits the impact of ransomware, malware, or any other security risks for your businesses. For example, data backups to the cloud have numerous built in security features which will limit the suspicious activity before it impacts your business. The next advantage or benefit can be improved customer retention. Because your business will go down, or the chances of business going down is almost very low because you already have disaster recovery plan. That's why the customer will not suffer, and when customer do not suffer, they are retained. So if disaster occurs, the customer questions the reliability of an organization's security practices and services. The longer a disaster impacts a business, the greater the customer frustration. Nowadays, we have lost patience, right? Even if the website takes more than 3 or 4 seconds to load, we just leave it. We go to other result. We do not have patience to wait. So a good disaster recovery plan mitigates this risk by training the employees to handle the customer inquiries correctly, and customer will gain confidence that the business is well prepared to handle any kind of disaster. So this also is included into disaster recovery plan. If anything goes down, then the customer support team should be always up and active. The last advantage is reduced recovery cost. Depending on the severity of the disaster, both loss of income and productivity happens. So a robust disaster recovery plan avoids unnecessary losses as system returns to normal soon after the incident. For example, you can use the AWS storage solution for cost-effective data backup. You can manage, monitor, and maintain the data while the business operates as usual. Right. So this is how the disaster recovery plan is quite important for us. So how does a disaster recovery plan work? So it focuses on getting the application up and running within minutes, right? So there are 3 components which we need to address. And for these 3 components, okay, let's just take a new slide over here. And those 3 components are, the first component is prevention. The other component is anticipation. And the last component is mitigation. What is prevention? As the name suggests, it it is to prevent something. So to reduce the likelihood of a technology related disaster, a business needs a plan to ensure that all key systems are as reliable and as secure as possible. So we try to prevent any kind of disaster. Okay, what kind of disasters we can prevent? We can prevent human errors. We can prevent technology failures. We can prevent the cyber attacks. All of such things are preventable. So natural disaster, we do not have control on natural disaster, right? But we have the control on network problems, security risks, human errors. So all of these can be prevented. So we should be setting up the right tools and techniques to prevent the disasters. We should have like testing software that auto checks all the new configuration files before applying them. So this can prevent the configuration mistakes and failures. Before going, let's suppose that a new feature is being added to our web application, right? So that feature must be first tested by a particular amount of traffic. Okay, so there you can use the weighted routing policy of Route 53. So here you would be preventing the entire failure of your business. So let's suppose 80% of traffic still goes to the old environment, only 20% goes to the new environment. Okay, so we can check whether it is working fine or not, and if it works fine, then we will be making it as our new production environment. So all such prevention steps should be taken wherever applicable. Then anticipation. Obviously, not all the disasters can be prevented. So we should be anticipating for any kind of failures. Anticipation includes predicting possible future disasters, knowing that how it would be impacting our business, that is knowing the consequences, and planning appropriate disaster recovery procedures. So it is challenging to predict what can happen, but you can come up with a disaster recovery solution with knowledge from previous situations and analysis. For example, backing up all business critical data in the cloud in anticipation of hardware failures on on-premises devices. So this is a very common way. You can have the backup of your on-premises in the cloud. Right? Then the last component is mitigation. Mitigation means how we react when the disaster happens. It focuses on reducing the negative impact on the normal business procedures. So all key stakeholders know what to do in the event of disaster, including updating the documentation, conducting regular disaster recovery testing, identifying manual operation procedures in the event of an outage, and coordinating a disaster recovery strategy with corresponding personnels. So even the disaster recovery plan should be tested. Okay, because what happens is, suppose we have created our DR plan, disaster recovery plan, in the month of March. The disaster occurred in December. So from March to December, there would be several changes which would have been done to our infrastructure. So the disaster plan might not work, or it might not fulfill the capacity that we require. So the disaster recovery plan should be revisited again and again. It should be tested again and again by creating the dummy disasters. Okay, so like that we can ensure that fine, our disaster recovery plan is also going good. So these are all three components of our disaster recovery plan. How to make different component resilient to our disaster. So there are different components in our infrastructure. Can be storage, can be compute, networking, databases. So how to make all of these four types in resilient to a disaster, because all of these are having different methods of making it resilient. So what are these different methods? Let's see one by one. So into storage, we have S3, S3 Glacier, EBS. Okay. So if we talk about S3, then how we can make S3 resilient? By default, S3 is resilient to availability zone failures. Apart from one zone standard infrequent, all other storage classes replicates the data across 3 availability zones, providing us with 11 nines of durability. So, but what if the entire region goes down? Because into the region we have AZs, right? This is our region. Inside of region 1, we can have availability zone 1, availability zone 2, and availability zone 3. So if any one AZ goes down, then okay, I do have my data of S3 into other 2 AZs. But what if this entire region goes down? Then what we can do? So for that, we have one technology, if you remember from the storage module, it's called as cross-region replication. So you can have your data replicated into other region. So both of the buckets would be in sync. So by that you can have the backup of your S3. Apart from cross-region replication, what else can you do? You can also enable object versioning. Now see, accidental deletion of your objects is also considered as disaster, right? So if the object versioning is enabled for all the S3 bucket, then it will keep the version history of the objects and will allow the recovery of deleted or overwritten objects as well. So this would be another disaster recovery strategy for S3. Then after, you can be using the CloudWatch alarms to monitor the S3 metrics, such as bucket size, the number of objects, the object size. So this can help in identifying the potential issues and taking the corrective action before they become critical. And lastly, you have to test your disaster recovery plan for S3. So periodically, you have to ensure that you have to test your plan to ensure that it is effective and up to date. Okay, the test would include failover test, data recovery test, and any other relevant kind of testing. The next storage option that we have is S3 Glacier. So yes, S3 and S3 Glacier are two different things, okay? So if we want the S3 Glacier disaster recovery plan, then what we have to do for that? So for S3, we have something called as vault deployments. So there are 3 options for vault deployments in S3. Globally available S3 Glacier Vault. Okay, let me just delete everything on the slide. The first is globally available S3 Glacier Vault. The second one is S3 Glacier Regional Vault. And the last one is, the third one, S3 Glacier Deep Archive. regional vault. Okay, so these three are the different types of vaults that we have in S3. Now, for disaster recovery plan, the regional vault in S3 Glacier can be the important component. So, a regional vault in S3 Glacier is a data repository that is deployed within a specific AWS region. So it offers low latency access to data, and it is suitable to the use cases that require faster data retrieval times. So with Regional Vault, the data is stored within a specific region and can be accessed through internet or direct connect. So basically, once you have created the Regional Vault, you can upload the data to it using the Glacier console. So it is important component of disaster recovery plan as it allows you to store critical data in a secure and durable location that is located within a specific region. So by replicating the data across multiple regional vaults, you can ensure that your data is available in case of regional disaster or outage. So that's where S3 Glacier Regional Vault comes into the picture. Lastly, we have the EBS volumes. So for EBS volumes, how we can ensure or how we can create the disaster recovery plan. So with EBS, you can have the feature of something called as snapshots. So what are these snapshots? These are point-in-time backups of EBS volumes. So you can create the EBS snapshots manually, or you can automate the process using AWS backup service. So what are these snapshots? So snapshots are something which can be used to restore an EBS volume in the event of disaster. Then just keeping the snapshot is not enough, right? So what you can do is you can replicate these snapshots, or you can be basically creating the copies of these snapshot across different accounts and regions. So even where, when the region goes down and you have stored your snapshot in that region, you can just access the snapshot from any other region as well. So replication is also important. Another important thing is you can use EBS volumes to have your on-premises backup. So you can replicate a service, you can replicate your on-premises data using a service called AWS Storage Gateway. So whatever data is there on your premise can be replicated to AWS. So if there is disaster on your premise data center, then you can recover your data from the cloud. Okay, again, when you are replicating your data into the EBS volume from your on-premises, you can again create the snapshot out of it. We can replicate those snapshots. Then there is one important concept called as EBS Fast Snapshot Restore. That is EBS FSR. EBS FSR, Fast Snapshot Restore. It enables you to access the EBS snapshot immediately, even if they are in cold state. So this will help reduce the recovery time objective of your disaster recovery plan. It means that the EBS snapshot would not take, the time to get activated. They'll be very quickly activated and recovered. So these are all the different options for storage in which we can be, creating the disaster recovery plans. Another important thing can be considered over here is Snow family. Now, how this will be helping us? So if you have data on-prem And if you want to create the backup of your data, then you can be using those Snow family devices. We have three different types of devices, right? We have snow cone, we have snowball edge, and we have snowmobile. So these are the three different kind of devices which can be useful for taking the backup of your data from your on-prem. Right. The next topic that we have is compute. So even when the disaster is striking, not only the storages will be affected, right? If one entire region is going down, then the compute services like EC2 or ECS, those things will also be affected. So, how to create the disaster recovery plan for that? So, when you think about EC2, in context of disaster recovery plan, it is important that you create your infrastructure very quickly back again. So, you can do that by launching your instances in separate availability zones. So, when one of the availability zone is going down, you can have your EC2 instances up and running into another availability zone. So, this would be um, protecting you from availability zone failures. So this is like, into multiple availability zone, we create the subnets, and into those subnets, we can launch our instances. But what if the entire region is going down? So in the context of compute, we should be able to, create the EC2 instance of same configurations quickly. So in that case, we use the AMIs. So whatever EC2 instances we are using, for those EC2 instances, the Amazon machine images should be pre-configured, right? So whatever EC2 you are using, you should be creating the image for that. We have already seen the demonstration on how to create the EC2 images. You can configure your own AMIs, or you can also have pre-configured AMIs given to us by AWS. AWS strongly recommends that you configure and identify your own AMIs so that they can launch as a part of your recovery procedures. Okay, so your AMI should be containing your operating system plus any pieces of your application stack. So you can, in case of disaster, okay, you can arrange the automatic recovery on of EC2 instance when a system status check of the underlying hardware fails. So the instance will be rebooted on a new hardware if necessary. But it will retain its instance ID, IP address, elastic IP address, EBS volumes, attachments, and other configuration details. For recovery to be completed, you need to make sure that instance automatically start up any service or application as the part of initialization process. So that can be given into AMI in the form of user data. For ECS, we know that for containers, we create the images. The containers are created with the help of images, right? The container image. So we should be having those container image, replicated everywhere, so that in case of disaster, we can recover the containers as well by spinning them off using that particular container image. We would be also looking at few disaster recovery strategies which would make much more sense in recovering our compute resources from any kind of disaster. The next topic that we have is networking. What if the networking goes down? So when you are dealing with a disaster, okay, you might need to fail over to another site. So when we need to fail over to another site, we need some networking modifications. We have to modify our network settings to initiate the failover and might also require the adjustment of the network settings. So AWS offers several services and features that you can use to manage or modify the network settings. So there are Route 53. So it includes a number of global load balancing capabilities. So we have seen the multi-value routing policy, right? What happens into that? We get the multiple IP addresses for one domain name, and our requests are only routed to the resources which are healthy. The next one that we saw was failover routing. So if our one infrastructure is going down and the health checks are not correct, then we can fail over to another environment. So Route 53 includes such kind of, load balancing and the failover capabilities. This can be effective when you are dealing with DNS endpoint health checks. The ability to failover between multiple endpoints and static website hosted in S3. Then we have elastic load balancers. Both of these services have health checks. So they will be giving the traffic only to the healthy infrastructure or only to the healthy instances. So what is the role of ELB? It distributes the incoming traffic across multiple EC2 instances. To achieve greater fault tolerance in your application by ELB providing the load balancing capacity that is needed in response to incoming traffic. So you can pre-allocate your load balancer to identify its DNS name and simplify running your disaster recovery plan. And Route 53 and ELB, both of them are already highly available components. You do not have to make disaster recovery plan for them, but in your disaster recovery plan, these both will help. So ELB works or spans across multiple availability zones. So if you want to distribute your traffic between multiple availability zones, then in that case, ELB would be helpful. If you want to, route your traffic across regions, then Route 53 would be a good choice. The next topic is recovery plan for databases. So we'll be talking about two databases over here, the RDS and the DynamoDB. For RDS, we know that we have multi-AZ deployment and multi-AZ failover. What happens into multi-AZ deployment? We have region, okay, and we have, let's say, two availability zones over here. We have EC2 instances and we have one primary database instance over here. So if you have enabled the multi-AZ deployment in RDS, then there would be one more standby instance of the database. So from this primary database instance, all the data would be synchronously copied or replicated in this standby instance. Okay, so both the database would be in the sync. In case of disaster, if one availability zone is going down, or say that the primary database instance fails, then the standby would be, okay, initially when the primary is up, then both the traffic can be go to that primary instance. But in case of disaster, our primary is failing, okay? Then what will happen over here? We have the EC2 instances. We have our primary database which got failed. So the standby instance that we had would be promoted to primary database and a new standby would be created into the availability zone. And they both again would be in sync and the traffic would be then handled by the promoted standby database instance. So this will allow you to protect yourself from the availability zone failure. Okay. So this is one thing. Another thing is you can use a snapshot to create a read replica in different region. If we want to deal with regional failures, then we can have the snapshot of RDS database. Yes, that is also possible. So we can take the snapshot of RDS database and create a read replica in a different region. This replica can be promoted to the primary in the event of disaster. So read replica requires a reboot. When we are promoting the read replica to the primary database instance, it requires a reboot and it has higher RTO than fail over to a standby instance. If we have multi-AZ deployment and if we are dealing with availability zone failure, then it would not take much time. But when we promote the read replica, because read replica is just meant for handling the read traffic. So if you want to promote it to the, primary database instance, then we have to make sure that it is handling both read and write traffic. So obviously that would be taking the time. Okay. Now what else we can do is, for disaster recovery of RDS, we can save a manual database snapshot or database cluster snapshot in a separate region. We can share a manual snapshot with up to 20 other accounts. So this would be again helping us in restoring our data from the RDS. The next topic or the next database that we'll be talking about is DynamoDB. So for DynamoDB, how we can create the disaster recovery plans? So there is a functionality of DynamoDB called as global tables. Global tables is basically creating the tables into multiple regions. So it is a fully managed multi-region, multi-active database that replicates your DynamoDB table. So you have to select what all regions you want in which you want to create this replication of your database. So into multiple region, you can have your database active. Okay, it would be in active mode. Where you originally created your database, that would be called as your primary region and rest would be called as secondary region. All the database would be into sync. A replica of your DynamoDB table across your choice of AWS region, that would be. But unlike read replicas, the global table would handle both the read and the write. Okay, it is not just used for read workload, it is the active database itself. So you have multi-active databases that will replicate your DynamoDB tables across multiple regions. So all the tables that have been replicated across multiple regions would be having the same table name and the same primary key. If one of the replica fails, then you can access the data using replicas in another region. So DynamoDB would be highly resilient to any kind of disaster if you activate this global tables. Okay, so that's about databases. Now we talk about recovery strategies. But before we go to the recovery strategies, I have one more important part over here. That important part is about infrastructure as code. We have talked about infrastructure as code before as well. What happens into this infrastructure as code is we basically create the templates for our infrastructure. Why I'm talking about this here is because it will help us a lot in creating the disaster recovery plans. If suppose you have one infrastructure up and running in US East 1, some disaster occurs and this entire region goes down. And if you want to replicate this particular infrastructure into another region, okay, then what you can do is you can use this template which you already have to deploy your infrastructure in another region. That would make it much easier for disaster recovery. Though this is not the thing which is being followed into the production, we have something more than that. And those are called as recovery strategies. So what are these recovery strategies? These help us to recover from the disaster. It helps us mitigate from the disaster. So when we'll be having these strategies? When we anticipate for the disaster. So this should be, already created before the disaster happens. So there are 4 types of recovery strategies that we are going to discuss. Backup and restore, pilot line, low capacity standby, and active active. So let us try to understand all these different types of recovery strategies. For that, I'll be taking you to the whiteboard and we would be looking at some visualizations over there. So the first type of recovery strategy we had was backup and restore. So we would be talking about this first, and then after we would just we would be just looking at the diagram first, and then we would be understanding what it is all about. This was a traditional approach, okay? This is not followed anymore. It is a traditional approach. It takes a lot of time to recover the entire infrastructure or the data or whatever. So I'll just have some diagrams over here and then we will be trying to understand it. Okay, let's take this. So we have this over here. Perfect. So this is the entire architecture that I wanted. So what we can understand from this is our backup. Okay, this is our restore environment. What is this? This is our remote server. And what is this one? This S3 bucket. Okay. Then here also, this is our remote server. This is our S3 bucket. And this is our, let's say, AWS disaster recovery region. So what happens into backup and restore is, in most of the traditional environment, data is backed up to tape and it is sent regularly offsite. So if you use this method, it can take long time to restore your entire system in the event of disruption. Already told you that, right? So S3 is one ideal location for taking the backup of your data from the remote server. So transferring the data to and from S3 is typically done through the network and is therefore, publicly accessible. Also use life cycle policies over here. If you optimize your cost for storing your backup, you can be using your life cycle policies. You can move the older backup to more cost effective solutions over time. In this example, a remote server is backed up to S3, okay? And lifecycle policy can be applied over here where you can be moving from S3 standard to infrequent access to glacier. So in case the remote server fails, okay, you have your data in remote, but in case it fails, you can restore your services by deploying a disaster recovery VPC. You can use CloudFormation to automate the deployment of core networking. And you can be restoring your system by retrieving the backups from your S3 bucket. And then adjust the DNS records to point to AWS instead of your on-prem. So this is how the backup and restore works. But this takes a lot of time. So what other option do we have? So the other strategy is, as we go towards the newer strategies, the recovery time will reduce, but the cost will increase. Okay, so other is pilot light. What happens into this pilot light strategy? First of all, again, let us visualize this. So I have this environment, which is the production environment, into which I'll be having my servers. Okay, these servers can be my web server, application server, as well as my database server. So let me just put a new database server over here. Now, into the pilot light, we have another environment that is called as recovery environment. Okay, and into that recovery environment, I will just copy and paste this entire architecture. Okay, and in between, let's say we do have the DNS. So, this is our production environment. This is our recovery environment. Into this, we have a web server. We have application server. And we have database primary instance. And here also the same thing, right? Web application. This is database, but this one is the secondary instance. And this one is our route 53. So whatever incoming requests are coming, okay, that would be first of all redirected to our production environment, and this primary instance and secondary instance, like they would be having the data replication on over here. And both of these web and application server, Okay, both of these would not be in running state. They would be just there into the stopped state, not into the running state. So with this pilot light approach, what you are doing is you are replicating your data from one environment to another by provisioning the copy of your core workload infrastructure. So you're replicating your web server, application server, and database in the recovery environment. Route 53 directs all the traffic to the production environment until the disaster happens. Okay, so for example, here all these goes down. Web server is off, application goes down, database goes down. All of these three are going down. Then what will happen over here? We just have to turn these on. We have to spin this on. Okay. So in case of disaster, we have to spin this on, and database would be into the on state itself. Okay. Because the data replication would be going on. Right. So the database's object storage, they are on, but the server is off. Right. And these servers will only get turned on when disaster happens. So your core infrastructure is always available. You just have to turn it on. Right. And then if you want, you can also have option to scale this up to your required settings. So this is relatively inexpensive, right? But it will take more time because we have to spend, but it is better than backup and recovery or backup and restore. So when the disaster strikes, we have to on these two servers, and we have to make changes to RDS so that it begins sending the production traffic to the recovery environment. Right. So that's what is pilot light approach. A good approach where you want to have the balance between the cost and efficient disaster recovery strategy. The next one that we are going to discuss about is low capacity standby. Low capacity standby. As the name is suggesting, we would be having our environment where there would be the entire environment but into the low capacity. How would that look like? So let's visualize it once more. Why I'm doing the visualization over here is because it will make it easier for you to remember the things. Okay. If you see it on slide or if you see it in making, it will change the things. It will make it easier for you to understand. So I'll just have the copy of this. Okay. So let's say that we are having 2 web servers, 2 application servers, and we have 1 database instance over here. What would then happen into the recovery environment is, I'll just copy paste this one. Okay. And then I would have 2 things here. What these 2 things will be about? These will be for our auto scaling group. Okay. Now you'll understand what I mean that as soon as I complete this entire infra. Okay, so we have our production over here. We have our recovery over here. And we have our DNS, that is Route 53 over here. So what will happen is, we have into production web servers. These both are web servers. These both are application servers, right? And this is database which is replicated to the recovery as well. The DNS would be sending the traffic to both of these environments. Here also I have web instances, application instances, and these to auto scaling group. Okay, these would be placed into auto scaling group. As the name is suggesting, low capacity standby means DNS would be giving the traffic to both of these environments. This would be also the active environment. The recovery is also the active environment, but at the lower capacity. So you can see that we have the auto scaling groups in the place. So what will happen over here is, in case of disaster, the auto scaling group will spin up and will be scaling out our resources to the desired capacity. So low capacity standby is similar to that of pilot light. The warm standby approach involves creating a scaled down but fully functional copy of your production environment in the recovery environment. So by identifying the business critical systems, you can fully duplicate the systems on AWS and have them always. This decreases the recovery time because you do not have to wait for resources in the recovery environment to start up. So in this example, we replicate the web servers and app servers in recovery environment as auto scaling groups, which can contain minimum number of instances and the lowest EC2 size possible. So this is not scaled to full production load, but it is fully functional. So it can be used for non-production workloads like testing, quality assurance, internal use. Okay, so also the copy of database is there. So both of the things are running fine, but if necessary, you can scale up your recovery environment to the production workload. In case your production environment becomes unavailable, okay, if this entire production environment goes down, then the recovery environment will automatically scale its capacity out in the event of failover, and DNS would be just sending the traffic then to the recovery environment. For your critical workloads or where you need smallest RTO possible, then in that case you can be using this low capacity standby. The last strategy is active active. Let us see that what is there in that active active strategy. So this is the last type of strategy that we have to discuss, which is active active strategy. Let's discuss this and understand what is there in active active. So let's again visualize the entire architecture over here. So because it's as the name, it is active active. Okay, I'll just create one environment here, and that would be active into the other one as well, other region as well. Okay, multi-site active active it's called as. So let's put all of these things into our environment. How easy it would be if we can actually put the instances like this in our environment. Okay, this is said. Now the same thing would be replicated to another site. I'll just take this and I'll put it over here. So what happens is, this time we'll not call it as production and recovery, we'll say it as production environment 1, and we'll call this as production environment 2, because DNS would be routing the traffic to both. The production traffic, okay. In low capacity mode, it was just, non-production workloads were going to the recovery. Here the production traffic would be going to both the environments. So these are our servers, web, these are our application servers, app. This is our database, which is getting replicated to the other site. So this is our database, web, app, and app. Right. So what happens over here is our DNS would be routing the traffic to both of the environments, and the second environment would be also the fully functional full capacity mode environment. So in case if this production environment is going down, no worries, because we have our other environments up and running, okay, in the active state with the full capacity. So here you do not also need to configure, you don't have to even change the configuration settings of DNS because already the traffic to production environment too. So this is what happens in active. This will reduce your recovery time objective a lot, but this would be the costliest option. Because understand that fully functional workloads are going on in both of the environments. If you need something like and your application is business critical, then you can think about it, or else it would be a very costly option. Without the requirement it would be very costly. Okay, so these were all 4 recovery strategies that we have. The next topic that we are going to discuss is AWS backup. So what is AWS backup? It is a fully managed service for backups. So it's actually called as also backup as a service. It is provided by AWS that makes it easy for you to have centralized backups, and also you can automate the backup of data across AWS services and on-premises resources. So what all services are being supported by AWS backup? Let us check those out. So we have the Elastic Cloud Compute support. Then we have S3 support. Okay, so automatic backups can be taken for Elastic Cloud Compute. It can be taken for S3. Then for EBS volumes. Now, over here what happens is we have different features like cross-region backup. So cross-region backup, cross-account backup, incremental backup. So there are all these kind of different features, and according to the services, these features are either available or non-available. So we would be just talking about, let's say, the services which are supported over here. Okay, the services are, as we are saying, EC2, S3, EBS, DynamoDB, RDS, Aurora, EFS, FSX for Lustre, for Windows, for NetApp, and for OpenZFS. So all of these services are there with support they are supported by AWS backup. And they support the feature of cross-region backup, cross-account backup, all of these services. Okay. The DynamoDB that we have over here will not be supporting our, this cross-region backup or cross-account backup. So if it is having the AWS backup advanced feature, if we have activated then it will support it, or else it will not support it. Other services are gateway, storage gateway. Then we have DocumentDB, Neptune, Redshift, TimeStream, VMware on AWS. We have VMware Cloud on AWS Outpost. We have AWS Cloud Formation, SAP HANA. So all of these are the different services, and mostly all of them would support cross-region backup and cross-account backup. Here the Redshift will not support it and SAP HANA will not support it. Rest all of them would be supporting cross-region and cross-account backups. So the features that I'm talking about are these. So one by one, I would be describing all of these features here itself. Okay. So first of all, as the name suggests, centralized backup management. So what is centralized backup management? AWS Backup will provide centralized backup console, a set of backup API, and CLI to manage the backup across AWS services that your application uses. So you can access your AWS backup using CLI, using SDK, and even through the console. So with AWS backup, you can centrally manage backup policies that meet your backup requirement. Okay, so what you would be having? You would be having the backup policies across your resources. You can have the central control over them. You can apply them on your AWS resources across AWS services, enabling you to back up your application data in consistent and compliant manner. So the console offers one centralized backup console for consolidated view of your backups and backup activity logs. So if you have the central view, central view of backup as well as backup logs. So what this will help us? It will make it easier for you to audit your backup and ensure the compliance. So when we are doing the backups, there are some compliance requirement that they should be encrypted, they should be following that PCI compliance, they should be HIPAA compliant. So all of those are also being ensured over here. We would be talking about when we talk about last feature. So the next feature is policy-based backup. So with AWS backup, you can create the backup policy known as backup plans. It is mostly commonly known as backup plans. So you can use these backup plan to define your backup requirement. That what do you want to back up? When do you want to back up? How frequently you want to back up? So you have to define the backup requirements and then you can apply it to all the AWS resources that you want to protect. You can create different backup plans to meet the different business or the application needs or the regulatory compliance requirements. So this will ensure that you are also, having a balance between cost and you are backing up all your data according to your requirement. So backup plans will make it easy for you to enforce your backup strategy across your organization and across your applications in a scalable manner. Right? So when you are creating this backup plan, then you have to select the backup rules. You have to select that how do you want to back up, what is the backup frequency, what would be the backup window so that you are not disrupting your business timings. So let's suppose that your application is, highly used during 9 to 5 time. Then you might not want to have your backup in that duration. So you can be selecting the backup window, or if you do not select, the default backup window is 5 a.m. UTC and it lasts 8 hours. So all of these things, the life cycles, that how do you want your backup to be, going from cold storage, hot to cold storage when it expires, or you can also delete those backups. So all of these things can be defined in your backup plans. Then after backup plans, we have tag-based backup policy. As the name is suggesting, you can apply your backup plans to AWS resources in wide variety of ways. One of the way is tagging them. So if you are using tags to tag your tag your resources. For example, you have EC2 instances, RDS, and you have let's say Dynamo. Okay, these are part of one application called as application X. Okay, so what will happen over here is you can tag these resources giving the name value pair. Application would be name, value would be X. Okay, so if you would have tagged it, it will make it easier to implement your backup strategy across your applications, ensuring that all your AWS resources are backed up and properly protected. So tags are always a good choice. Okay, it is a great way to organize and classify your resources. You can have up to 50 tags applied. So more and more tags should be applied for good categorization, because it also does not cost us, but it makes our life a lot simpler. Then we have lifecycle management policies. So AWS backup enables you to meet compliance requirements while minimizing your backup storage cost by storing the backup in low cost storages. Okay, so backups are cold storages. You can configure the lifecycle policies that will automatically transition your backup from warm storage to the cold storage according to the schedule that you are deciding. Then we have the cross region backup. So using the AWS backup, you can copy the backup to multiple AWS regions on demand or automatically. It depends as a part of your scheduled backup plan. So cross region backup is particularly valuable if you want to have business continuity or you have any kind of compliance requirement to store the backup at minimum distance away from your production data. Then in that case you can be using the cross region backups. It would be a very good choice. Also it would be providing high availability as well, right? Okay, then we have cross account management and cross account backup. So what happens here is you can use your AWS backup to manage your backups across all AWS accounts. So we know that when the firm is huge, then there can be multiple accounts that can be organized using AWS organizations. Okay, just a second. I'm just writing it bad. Organizations. Right. So all the accounts under this organization structure should be backed up using AWS backup. So with cross account management, you can automatically use backup policies to apply the backup plans across your AWS accounts within your organization. This makes compliance and data protection efficient at scale, and it also reduces operational overhead because you don't have to do the repetitive, tedious work in all of the accounts manually. You can apply it automatically to all the accounts under organization. So, manual duplication of backup plans would be eliminated over here. Can also copy your backups to multiple different AWS accounts inside your organization. So this way you are basically fan in. You can fan in backups to a single repository account, and then you can fan out your backups for greater resilience. Because what are we saying? AWS backup provides us with centralized backup management, that is fanning in. But if I want to have the disaster recovery consideration over here, then I will fan out, means I will be putting my backups into many accounts just to ensure the resilience. So before you can use this cross account management or cross account backup, you must have existing organization structure configured using AWS organizations. Okay. The next feature of AWS backup is auditing and reporting with AWS Backup Audit Manager. So AWS Backup Audit Manager will help you simplify the data governance and compliance management of your backup across your AWS accounts. So it provides built-in customizable controls that you can align with your organization's requirement. You can also track these controls and see if anything is going non-compliant. It will help you locate specific activities and resources that are non-compliant to the controls that you have applied. Can generate your daily reports that you can use to demonstrate the evidence of compliance with control over the time. Right. Then another important feature is incremental backup. So AWS Backup efficiently stores your periodic backups incrementally. The first backup of an AWS resource backs up a full copy of your data. Then after, whenever the backup is taken, okay, for each successive incremental backup, only the changes that are done to your resources are being backed up. So incremental backup gives you the benefit from data protection of frequent backups while minimizing the storage cost. Then you have full AWS backup management. Some of the resource type will support this, not everyone. Okay. So we have independent encryption. So AWS backup will automatically encrypt your backup with KMS key of your AWS backup vault instead of using the same encryption key as your source. So this will increase a layer of protection over here because it will use yet another key created by KMS. Backup ARN. So all the ARNs, that is Amazon resource name, will begin with ARN, AWS backup. So this will allow you to create the access policy that applies specifically to the backup. Okay, so the ARN name of your backup would change. It will not be like ARN, AWS, and source resource. It will not be like this. It will be like this. So if you want to attach different policies, different access policies using IAM to your backups for identifying or giving the privileges to the users to these backups, then you can create the separate policies for that. The next one is backup activity monitoring. So also one more thing is left into full backup management, that is centralized backup billing. So charges for AWS backup will appear under backup. Okay, it doesn't matter you are doing the backup for storage or there are charges for data transfers, restores, early deletions. All of that would be categorized under backup instead of appearing under each supported resource. It would be easier for you to see that how much charge it is being going for AWS backup. Then we have backup activity monitoring. So backup activity monitoring, it will provide you a dashboard that makes it simple to audit backup and restore activity across AWS services. So with few clicks on AWS Backup Console, you can view the status of recent backup jobs. You can also restore the jobs across AWS services to ensure that AWS resources are properly protected. Also, backup can integrate with other AWS services like CloudWatch and EventBridge. CloudWatch will allow you to track metrics and create alarms according to the AWS backup. EventBridge will allow you to view and monitor AWS backup events. It also integrates with CloudTrail. So CloudTrail is a very important service which will give you a consolidated view of backup activity logs that make it quick and easy to audit how your resources are backed up. It also integrates with SNS, providing you with backup activity notifications, such as when the backup is succeeded, or when it failed, or when the restore has been initiated. All of these services can be integrated with backup for getting a good understanding that how the backups and restores are working. Lastly, two features are left. Secure your data in backup vaults. So the content of each AWS backup is immutable. It means that no one can alter the content. Obviously, we would want that, right? Because if anyone is altering the content of our data, then what would be the meaning of the backup? It would be the security breach, right? So no one will be able to alter the data that you have backed up. It further secures your backup in backup vault, which separates them safely from their source instances. For example, your vault will be retaining your EC2 and EBS backup according to the lifecycle policy that you choose. Even if you delete the EC2 instance, the source EC2 instance, and the source EBS volume, your backup would still be there. So these backup vaults are encrypted. And resource-based policies can be applied to them to define who has the access to your backup. You can define access policies for a backup vault that define who has access to the backup within that vault and what actions also they can take. This provides a simple and a secure way to control the access to your backup across AWS services. You can use the backup vault lock to prevent anyone, including you, from deleting the backups or altering their retention period. So this is just like, the object lock or the deletion protection that we have on DynamoDB and RDS. So you can delete RDS or DynamoDB till the time the deletion protection is on. So here also you can have a vault lock to prevent deletion. So this vault lock helps you enforce write once, read many model and add another layer of security to your backup. The last feature over here, the most important feature, is support for compliance obligations. Whenever you are doing the backup of your data, organization will require some kind of compliance with some standard compliance programs. So it helps you, the AWS backup will help you meet your global compliance obligations. What scope it follows? It follows the scope of, let me just erase everything. It is meeting the compliance from FedRAMP High. It is meeting GDPR, SOC 1, 2, 3, PCI, where you have credit card information or any kind of personal details, then you have to be PCI compliant. Then you have HIPAA and other as well. Apart from this, many more compliance are also there. Okay. So these are all the features of AWS backup. And this brings us to the end of this particular module. But before we end this, we had so much of theory over here. So let us try to understand what all things we discussed in this particular module. So let me add one screen over here. Let's quickly revise what were the concepts that we learned. So, first of all, we started with disaster recovery. We understood that what is disaster recovery. Okay, don't know what spellings I'm writing. Okay, it is disaster recovery. So, there are three components over here in disaster recovery. Okay, firstly, we try to prevent the disaster. So there are few disasters which can be prevented, like human errors, networking problems, cyber attacks. All of these can be prevented. But if the disaster is not prevented, then we anticipate disaster, which means that we are actually expecting the failure. Once we expect the failure, we plan for it, right? And the last thing is prevent, anticipate. And when the actual disaster occurs, you have to mitigate from that disaster. We have talked about two important criterias over here, that is RPO, recovery point objective, and RTO. RPO is how much data loss you can suffer. RTO is how much time, maximum time, should you be taking for recovering your business. So these were the disaster recovery introduction. Then we understood that how to make our different components in the infrastructure resilient to the disaster. There we discussed about storage. So there we understood for S3 and S3 we can do the cross region replication, right? For EBS we can have snapshots. For compute, we can have AMIs and the container images. Networking, basically, we talked about Route 53 and ELB. So both of them are highly available component. So they do not need the disaster recovery plan or strategy. They are actually useful when we are creating the disaster recovery plans, right? And lastly, we discussed about databases. Right. So into databases, we discussed about RDS, multi-AZ deployment. We can also have snapshots of RDS for backup. We discussed about DynamoDB global tables, which would make the DynamoDB highly resilient to any kind of disasters. So after discussing all of this, we went to disaster recovery strategies. We discussed 4 strategies over here. The first strategy was the backup and restore. This is the most traditional one, not used, very popularly now. Then we have pilot light. Then we have low capacity standby. And then we have active act. As we go down over here, the cost will increase, but the RTO will decrease. Right? The time taken to recover our business back in active state would be reducing here as we go down. After discussing the recovery strategies, we discussed about AWS backup. This is backup as a service provided to us by AWS. And we discussed about various features and the services which are supported by AWS backup. So these were the all things that we discussed over here in this particular module. Important module, though it is theoretical, it is kind of important to understand that as a solution architect, we just not be creating the infrastructure and forgetting about it. We should be ready for any kind of disaster that happens to our infrastructure. And the goal is to reduce the downtime of the business. We do not want to let our end users or customers suffer because of any kind of disaster. And even in case of disaster happens, we should be having our customer support team ready for answering all the queries of the users. So this is our final module, right? This is the last module for this entire course, and that's it for this particular module. Thank you so much, everyone.